Welcome back to another video, everyone. Thanks for tuning in. In this one, we'll be taking a look at more surface areas and more shapes, and that way we can really kind of refine our approach and process to these and see that as long as we understand what is being asked of us, we can go ahead and get the right answer every single time. Let's jump right in. Now, in your formula booklets, you are given this, that the area of the curved surface of a cone is pi RL. Pi is pi, R is the radius, and L is the slant height, meaning this height. So that's important to realize. It's not the height, it is the slant height. It's different. So let's say that this cone has a radius of 5 centimeters. And let's say the total surface area is 300 square centimeters. So let's find the slant height of the cone. Okay, so now if I want to find the slant height of the cone, I know that 300 square centimeters is my total area. I have pi, I have r as 5 centimeters, and I don't know what L is. So again, I can use NSolve, I can isolate for L, figure out what that is. L is going to be 14.1 centimeters. Sorry, the square centimeters. 14.1 to 3 significant figures. There we go. Just moving some things around. So now let's find the height of the cone. So what's important to realize here is that if you drop down this height right here, this is going to be your height. Then your slant height is over here, which in this case is going to be L. So how do I figure out what H is? Well, again, Pythagorean theorem. L squared is going to be 5 squared plus this H squared. So H is going to be equal to the root of the slant height squared minus 25. Again, use your ANS function or your store function for L, and you will find that the height is going to be 13.2 centimeters. There we go. So now let's see how we can solve for the volume of the cone. Because the volume of a cone is just 1/3 area of the base times height. So the volume of this cone is 1/3 area of the base is going to be pi r squared times your height, which is going to be h. Okay, so now you want to use your unrounded answer over here. And as long as you put in all of those values correctly into your calculator, go ahead and pause the video, maybe check. But you should be getting 345 cubic centimeters to 3 significant figures. Okay? All right, now let's take a look at another type of problem where we're going to be using two shapes in combinations with each other. Okay? So in this case, we kind of have the classic ice cream that's put into a cone. Okay? So you have half of a sphere, also a hemisphere, and then a cone. Now, the cone has a vertical height of 8 centimeters and a radius of 3.5. So let's figure out what the slant height is. So we just did something very similar to that, where this is the slant height here, here's the radius here, here's the height here, and that's going to make a 90-degree angle, and my slant height is the hypotenuse. So L is going to be equal to the root of 8 squared plus 3.5 squared. So L is going to give me a value of, actually, I'm going to leave it in kind of not 3 significant figures for right now. 8.732. Again, use your ANS function, use your store function. So now let's go ahead and let's calculate the surface area of the wafer. So the wafer is that delicious ice cream cone that you are talking about right here. So what is the surface area of a, well, this is a cone. So the surface area of this cone is going to be equal to pi RL. Something to notice is that we're not taking in the bottom or the base into account because we got an ice cream cone on top of that. We can't actually touch that. The only part that we need to, like in this case, let's say wrap for this, with napkins or something, would actually just be the curved area of the cone, which we were given in our last problem and also in our formula booklets is pi RL. So the surface area is going to be equal to pi times the radius, 3.5, times L, which again, I want to use as specific as a number as I possibly can, but I will go ahead and find that the surface area is going to be, again, I'm going to surface area. I'm going to just keep that in 3 significant figures. I'll have 96.0 square centimeters. Now, if you're wondering, why did I do this in 3 significant figures but not this? That's just because I knew that I was going to find the surface area down here, meaning that I had to use the slant height, meaning that I had to use this number as specific as possible. But the surface area is just kind of like more of a numerical value that we need to come up with. And 96.0 square centimeters is often more helpful than having this decimal run on forever and ever and ever and ever. So now let's calculate the total volume of ice cream. So I see that my volume is equal to 1/3 pi r squared h for the volume of the cone. And then now for the sphere, it's 4/3 pi r cubed. that is for the volume of a sphere, not a hemisphere. Remember that a hemisphere is going to be half of that. So the volume would be what? That's going to be 2/3 pi r cubed. Okay, kind of important to know. Actually, not kind of, it's very important to know. Let me go ahead and move that up there. Volume of the, I'll put that as an H for hemisphere. So now, the total volume is going to be equal to, well, whatever this cone is. That's 1/3 pi 3.5 squared times the height h plus 2/3 pi r cubed, which is going to be 3.5 cubed. What I have to recognize here is that the volume of this cone plus whatever the volume of this top shape is, if I add those together, that is going to give me the volume or the amount of space that this entire thing is going to take up. Okay, so now if I put that all in my calculator, round to three significant figures, I am going to get the volume is about 192 cubic centimeters. Okay, so again, that's just recognizing different pieces of information that we need in the problem and then putting it all together at the end. So as you can see, even if we have a combination of shapes, we can still use what we know in terms of surface area and volume to figure out what the volume is of these new hybrid or kind of combination shapes. So again, be sure to use the full answer in your work, not just the abbreviated answer, because sometimes that can lead to some rounding issues. And again, just remember to break these shapes down into their smaller, more individual shapes and those formulas exactly. And then if you have to multiply it by half, then you have to multiply by half. So I hope you found this helpful. In our next video, we'll be taking a look at even more hybrid shapes and how we can use, again, the same formulas that we know, but in different ways in order to solve more complicated problems. All right, see you all there. Take care and have a good one.